Hello, grade 10 students, and welcome back. Today, we will solve question 4 from lesson 5.3, Forces in Two Dimensions, part 7. So, let's get started. A system of forces acts upon an object as shown in the adjacent free body diagram. The net force on the object is given by this. Now remember, for the first input, this represents the x component of the F net. For the second input, this represents the y component of F net. Now, as we know, all forces are measured in Newton. So also the individual forces should be expressed in Newton. Determine the magnitude of F1 and F2. According to this free body diagram, the magnitude of F2 as well as the magnitude of F1 are unknown. However, we have the angle corresponding with each of these forces as well as the angle between F2 and F3. So let me first denote the 20 Newton to be F3. We know that whenever we have a force does not align along one of the axes, such as the x-axis or the y-axis, not even here or there, in this case, we need to break down the force into two components, the x component and the y component. So let's get started. Now, in order to decompose F1, you should write it as F1x and F1y. Now, let me draw for you the F1x and F1y. Now, starting from the tip of F1, projected along the x-axis, projected along the, x-axis here and y-axis there, and you will come up with what? The first force, the first component, and the second component. This force here represent the fx1 and here represent the fy1. However, we need to find the magnitude of each of these forces. Now, in order to find the magnitude of each force, we need to use the cosine and sine. Now, this angle here represent the angle between the force and one of the axes. Now, since the angle here is measured with respect to the y-axis, this is the y-axis here. So this force has an angle from the force to the y-axis, then we must apply the cosine on or for the Fy. So let me write here that F1y is given by F1 cosine the angle. However, also here we should describe or add a sign to represent the direction. Since the direction is downward, then the sign must be negative. So let me add here negative sign. Now for the fx1 or 1x, doesn't matter. You can swap between the x and y, x and 1. Now this direction is negative. This is why I need to add the minus here. And since we have applied the cosine theta, now we need to apply the sine theta for the second component. So this is f1 multiplied by sine theta. So we will get that minus, since f1 is not given, I will keep it unknown. The sine, now the angle is 60, as well as here, minus f1 cosine 60. Now, this can be evaluated using the calculator, or as well as this one. So I will keep the F1 unknown in both of the equations. So minus f1 and minus f1 here. Now let's evaluate the sine 60 and cosine 60 using the calculator. So let me do it here. So let's start with sine 60. And the answer is radical 3 over 2. You can write it as radical 3 over 2. However, for simplicity and to avoid doing complicated operation using the calculator, we will see that next. I prefer to write it in decimal form. So let me write it as 0.866. 3 digits after the decimal are enough. So 0.866. This is the value or the magnitude of the x component. The same thing can be said for the cosine of 60. Let me find out what will be the cosine of 60. And it's going to be half. Let me write it in decimal form. So 0.5. And this is the magnitude of the y component. So what do we have here now? We have the expression of the f1x in terms of f1 and the given sine of the angle, as well as for the y component in terms of f1 and the given angle or cosine of angle. Now we're going to repeat the same thing for f2. Now again, f2, it doesn't align along one of the axes, so we must break it down, which means we're going to project f2 along the x-axis and along y-axis. Like here and there. As we can see, both are pointed in the positive direction or to the positive direction. This one is pointed to the positive direction as well as this one. This is why for f2x and f2y, we will have positive here and positive there. Later, you will get familiar with this orientations and no need to evaluate it in this way. Now, before I start completing the expression for each one of them, let me pay your attention that we are interested in this angle between the x-axis and the force, not the angle between the first force, which is F2, and the second force, which is the F3. According to the sketch, this angle, the 90 degree, is given for the angle between F2 and the F3. And this is not the case here in the projection. We must know what will be the angle between the x-axis or the y-axis and the force. Here in this case, I can find the angle between F2 and the x-axis by doing a simple calculation. Let me explain how we can do that. Now, since this is the 90, if we remove from the 90 20, what left is the angle between the x-axis and the force. So this can be written as 90 degree minus 20, which is equal 70 degree. Now 70 degree here is the angle between the x-axis and our force. This is actually what I'm going to use in order to apply the breaking down or the decomposition technique. Now let's get back again here. We know what is the angle. The angle measured should be 70. And since the angle is between the x-axis and force, this is horizontal angle with respect to the x, which means the cosine should be applied for the x component. So let me write here that f2 multiplied by cosine theta, and here f2, it will be sine theta. Remember that. We just look at the theta. If it's measured with respect to, WRT means with respect to, if it's measured with respect to the x-axis, then we should apply to the x component. And by default, the y should be with the sine theta. And if the angle is with respect to the y-axis, then instead of applying the cosine for the x component, we're gonna apply it for the y component. So now cosine should be here to give the birth of the fy. And since we have used the cosine for the fy, we're gonna use the sine for the fx. So first, whenever you want to decompose any force, you just look at the angle. And you should ask yourself, is this angle with respect to the x-axis? Did we measure it with respect to the x-axis or with respect to the y-axis? Now for our case here, the 70 degree, we have measured the 70 degree from the force to the x-axis. This is why I have applied the cosine to the fx and the sine to the fy, and this is actually what I did in the second case. In the first case, where f1 is our force, the measured angle is with respect to the y-axis, which means this is the second case, fx, f sine theta, and now the cosine, it should be applied for the fy component. And this is what I did in the first case. Remember that in the decomposition, our target is to break down the force into two components. To give the birth of one of them, let's say fx, let's say we are in the first case, then I must apply the f with the cosine to reduce it into fx. And for the second component, we apply the sine to reduce it to fy. This was a quick revision about what we have learned in the past few lessons. Now let's get back to work and complete the solving. Now for the f2 is not given again, so we don't know what is the f2. Let me keep it unknown. f2 cosine the angle, this time the angle is 70 degree, and f2 sine the angle, again it's 70 degree. Now we know that we can evaluate the sine here and the cosine there using the calculator. So let's evaluate each value using the calculator. Now the cosine, let's start with the cosine of 70, and the cosine of 70 is 0.34. So f2 multiplied by 0.34, and for the sine of 70, it will be 0.939. I will write it only 0.93, it's fine. So let me pay your attention to something very important. The n here is just a unit. It has nothing to do with my expression. These are units, and I need to add the units for each force. Moreover, let me do something to make unification, or to make everything is consistent with each other. So since I have decided to take only two numbers here, two digits after the decimal, I will do the same thing for f1. If you want to keep it, it's fine. It won't change the outcome. Now for f3, I will apply the same thing. However, for f3, this is f3, we have the force, so we should use it in order to find the components. No need to write f3 similar to the previous cases, because in the previous cases, the f1 is unknown as well as f2. However, f3 is known, which is 20, so we can substitute it here. Again, f3 can be decomposed into two components since it's not aligned with one of the axes. So f3x and f3y. Now what about the sign for each one of them? Let me project the force along each axis. So let's do that together. So along x-axis and along y-axis. This is the f3x, and here we have f3y. So the direction here is to the positive, the direction here is to the negative, which means f3y should be negative, f3x should be positive. So let me add this here to my work. Now, where should I apply the cosine? Since the angle here is with respect to the x, you should apply the cosine for the f of x. So I'm gonna write f3 cosine the angle, f3 sine of the angle. Now, f3 is given, so let me substitute it. Multiplied by cosine of 20, as well as here. Now, let's use the calculator to evaluate the magnitude of each component. So let me write here 20 multiplied by cosine 20, and the answer is 18.79. We can write it as 18.8. Again, for the second force or the second component, we have minus 20 multiplied by sine of 20, and the answer is minus 6.84. Okay, so let me run the matrix notation now for each one of them. The F1 is given by the x component with the y component. The x component is minus. Now, it's more common to start with the number instead with the unknown. So we can swap between the F1 and 0.86. So I will write 0.86 multiplied by F1. Do I need to add the unit here? Not necessary. Unit should be out of the bracket, next to the bracket. Why did I choose that? Because in math, we are familiar to write or we usually write the unknown as a second place, in the second place, like this one. Let's say, usually we write 3 times x or minus 3x, not 3x times 3 or minus x times 3. So more commonly to see this instead of that. Both of them are correct. However, we always start with the number. This is why I prefer to use this order when I want to write my components. Now, what about this one? Again, this is minus 0.5 multiplied by f1. So f1 here and there are unknown. Now, what about f2? I will follow the same thing. Now, f2 multiplied by 0.34, I would write it as 0.34 f2 and 0.93 f2, close it, write in. Now finally for f3, we will follow the same order, 18.8 and minus 6.84 Newton. Now, I want you to pay attention to the detail. Double check your values. Maybe you have missed one of the signs here or there. So minus, 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 the numbers. This is x, this is y. Always the first line will be for the x component, the second line for the y component. So if everything is fine, everything is correct, in the correct place, we can jump into the next step. Now we have everything that we need to start solving the problem. We didn't even start. Now the F net is equal to 3 over 2, 3 2 Newton. We know that the F net in general is given by this formula. F net is equal F1 plus F2 plus F3 plus F4. As long as we have more forces, we just keep adding the forces together. Now, let me write for you the matrix notation with the magnitude or the component for each of these force, each one of these force. Now, for the F net, we have 3, 2, so let me write here 3, 2, which is equal. For the F1, we have minus 0.86 F1 minus 0.5 F1. For the F2, 0.34 F2, 0.93 F2, and finally 18.8 minus 6.84. This is the third force. However, this equation can be simplified more because one of the terms is known, like this one here. So we just move it to apply the like terms operation. So we're gonna combine this term with this term. This is why I prefer to move it to the other hand side, and don't forget that the sign here will change from plus to not minus. So let me rewrite again that 3, 2 minus 18.8 minus 6.84 equal, again, minus 0.86 F1 minus 0.5 F1 plus the remaining Now we can simplify this side such that we can subtract 3 with this first line with the first line, and the second line with the second line, the input in the second line for the second matrix. Pay attention to the minus. Here we need to subtract. So 3 minus 18.8 and 2 minus 6.84. As a result, we will get, so 3 minus 18.8, this is just minus 15.8, and 2 minus 6.84, this is just 8.84. You can double check using the calculator, which is equal the same right hand side. Minus 0.86 F1 minus 0.5 F1 plus 0.34 F2, 0.93 F2. Now, as you can see here, we have two unknowns. So the F1 is the first unknown, the F2 is the second unknown. This equation is known as system of equations, and the order or the number of equations here is, or are 2. So 2 equations with 2 unknowns. In case the number of the unknowns equivalent to the number of equations, so if we have number, this is the notation, this notation is known as the number. If the number of equations is equal to the number of unknown, then we can solve it using the simultaneous solution. Now, since the simultaneous solution will take a long time to complete it, I prefer to use the calculator. So let me use the calculator and teach you how to use the calculator to solve this system of equations. Now let's assume that the f1 is the same of x. So we have here x, x, y, y. And here we have the constant. Look, after the equal, we have the constant. If you would like to rearrange the equation such that you have equal the constant, it's fine. But we can handle this by using the following method. First, press on the mode. Let's press on it. And we will get this list. We're gonna choose 5 for the equation. EQN here represent equations. Now, we're gonna choose 1 because 1 represent the simultaneous equations with 2 unknown. So this represents the simultaneous equations or the simultaneous solution for 2 unknown. So let me press 1. And we will end up with this equation. The first entries here, the A column represent the first unknown, the factors of the first unknown. For the B, this is the factors of the second unknown. And for the C, from the letter C, you can say this column represents the column of the constant, which means in this case, the minus 15.8 and 8.84. So keep in mind that the constant should be after the equal with the numbers. So this one here. Now let's start inserting the factor. Remember, we're gonna insert the factor, the unknown. This program, or let's say this technique, is designed to calculate the unknown f1, f1, f2, f2. So let me write the minus 0.86 equal. Now, I prefer to start line or column by column. So the second entry for the A column is minus 0.5. So look here what we have. The same entries as here. Now we complete for the second unknown. B represent the second unknown, which is in this case F2. So let me write here 0.34 equal. Let me go back. Sorry. So I will start adding the values again. 0.34 should be up. And for down, we need to change this. This is not 0.34. It's 0.93. Equal. Now we have everything almost done. We have all the entries for the first unknown, all the entries for the second unknown. We need to add now the constant. The constant can be found here after the equal. Minus 15.8 equal. Again, I did the same mistake. So it should be up. So minus 15.8. Now go down. And we should add the last entry, 8.84. Now, pay attention to something very important. The first here, A, represent the first unknown. The first unknown is F1. The second unknown is F2. Now, after you press the equal, the calculator will show you the values of the first unknown and the value for the second unknown. So let me show you. So here X represents the first unknown. However, the calculator cannot know if the question is related to physics or not. However, the first unknown is F1, so this value represents the first unknown. If you got 27.7, it's fine, because maybe you used the fractional form of each of the inputs, you know, because, for example, minus 0.86, it's radical 3 over 2. So sometimes you will find a small error in the solution. It's fine, it's accepted, don't worry about that. So let me write that 28 is the first force, and if we press equal again, you will get the value or the magnitude of the second force, which is in this case F2, and F2 is 24. So we have 28 and 24 for the second force. So final step, F1 is equal 28 point something, and F2 is equal 24 point something, 0.6. My recommendation is to resolve the same problem over and over again to get familiar with the technique, because the only way to master something is by repeating it. That's it for today. Thank you for watching, and see you soon in a new video.